Hello and welcome to another edition of the TES Secondary Maths Resource of the Week with me, Craig Barton. Now, I hope you'll forgive me here, but I'm returning to one of my all-time favourite TES authors, Andy. He's flipping brilliant. You'll have seen me feature some of his wonderful resources in the past. I love the spiders, I love the explosion activities, I love the lessons, I love the code breakers. He's my maths hero, I think. I'd get him knighted if it was up to me. And I just couldn't resist sharing this resource as well, graph matching. Because, and this is purely selfish, I think this is one of those things that kids struggle with a little bit. Let me, excuse me, let me explain to you what I mean. I think there's two specific skills that kids need to be good at when it comes to graphs. And by graphs, I'm talking predominantly here straight line graphs and quadratic graphs. The first is actually plotting graphs from a table of values. And I think kids tend to be fairly decent at that. So if you show them an equation, y equals 3x plus 1, and say, draw that graph, standard exam question, kids are pretty good at substituting in, plotting coordinates and drawing a straight line. And as long as they're good at negative numbers, algebraic substitution and so on, they shouldn't go too far wrong. But of course, there's another major area of graphs that isn't covered by, and that is actually understanding the equations of graphs themselves. So what does the 3 in front of the x represent? If I see an equation of y equals x minus 3 all squared plus 1, can I sketch that quadratic? What does the minus 3 mean? What does the plus 1 mean? And so on. And that's not quite as easy to get kids good at, in my opinion. This activity is absolutely wonderful for consolidating their understanding, assessing their understanding, and also developing it as well. So it is a graph matching activity, no surprise there. It consists of 3 files, a PowerPoint, a worksheet, and, as Andy often does, provide the answers. And it's probably easier to show you just the PowerPoint first. So it starts off really, fairly straightforward with a straight line graph matching activity. So the idea is that kids there have 5 equations. They have 5 diagrams and they have to match them, match each one. Now, if your math skills are as good as mine, I've spotted there that there's one more equation there than there is graph. But if I show you the worksheet, then you'll see that the idea is they have to match them up, excuse me, and then the blank grid, they need to draw in the equation that hasn't been matched to a graph, if that makes sense. Now, again, you'll notice that it starts off nice and simple, but you've got opportunities to discuss some really good misconceptions here. So you've got y equals x combined with y equals minus x. I love that one, 2 minus x, and you've got x plus 2. So can kids distinguish between the two? What role does the 2 play there? What role does the 2 play there? And why are those graphs different? How are they different? And so on. It's a wonderful activity because of the choice of the questions to open up that kind of discussion, and it's just really nicely set out. But then it continues in complexity. So again, this time we have straight line graphs here, but now we're changing the coefficient in front of the x. So what role does that have? How are 2x plus 1 and minus 2x plus 1 different? How are 2x plus 1 and 3x plus 1 different? What's the same? What's different about them? So we get kids looking at intercepts, calculating gradients and so on, all the big skills. But then it continues. So then we start to introduce quadratic graphs here. And again, I love the way it starts off really basic with just keeping the coefficient on x squared as 1, but just sticking a minus sign in, adding things, and then chucking a 2x squared into the mix. And I should say the answers are not only provided on the worksheet there, they're also provided really nicely on the PowerPoint as well, which is absolutely ideal. I mean, it just looks nice, right? It's just lovely looking. Then I love this here. So then we get graphs, quadratic graphs displayed in almost complete in the square form, and it's going to build up to this where we start chucking a little number at the end as well, looking at transformations and so on. So you see you're getting a full range of things here. Then we start to look at, I love that. So then we get quadratic curves where this time factorization needs to happen, and those kind of things there. Y equals x squared plus 3x. I have A-level kids who are like, what? Well, I don't know how to do that. I can do this one, but I can't do that one. Well, just factorize it then. But they don't seem to spot that unless they seem to think unless it has that number on the end, like plus 3 or whatever, they can't factorize it. But just taking a simple factor of x out, and it just brings out those discussions. And then the final one here, we start to chuck in different types of graphs. Perfect for the GCSE. We have our cubic, we have our reciprocals, and so on. So how do we best make use of this? Well, the beauty of it is that they're separated, these things. So if you've taught your year 7s or year 8 straight line graphs, then you can use this matching activity with your year 7s and year 8s. Likewise, if you've done more complicated ones, if you've just started introducing year 9s to quadratic curves, then you can use matching activity 3. But I think the best way to use this, the way to get the most out of this, is to do it as a graphs revision lesson with year 11s. Say you've got year 11 higher tier students, you're a couple of months out from GCSE or a couple of weeks out from GCSE. Give them all of these. Give them it as a graphs challenge lesson. Let's spend 50 minutes or an hour or whatever on this. And because it does something really, really important. It allows kids to spot connections between straight line graphs and between quadratics, and even between other graphs as well, like reciprocals and so on. They start to realize that minus sign, it means the same thing whether it's a quadratic graph or whether it's a straight line graph. The number on the end, the intercept, means the same thing whether it is tagged on the end of a quadratic graph or it's tagged on the end of a straight line graph or a cubic graph or whatever. So kids start to make connections, and connections are the key. Graphs shouldn't be seen as an isolated topic where it's, right, okay, let's learn a load of rules for straight line graphs. Now let's learn a load of rules if it's negative straight line graphs. Let's learn a load of rules for quadratics if they look like this. Another load of rules if they look like this. If kids can start to bring that knowledge together, integrate it together, spot connections, they're going to have a more holistic understanding of it. And the other thing I'll say when using this is fire up Desi. Get old Desmos involved. You can plot graphs till the cows come home on here, and you can show kids that, okay, if I'm going to take one like this, what difference is it going to be? What's the same? What's different? And it just so flipping fast to do. So we had one along those lines. Why is that the same? Why is that different? Let's hide that to make that more apparent. Let's hover over here to see the intercepts and so on. So I just think this is absolutely a wonderful resource for revising the whole of graphs. And personally as well, I'd use this first week with A-level students. Coordinate geometry is so important for those first stages of A-level or AS. Get this wheeled out in the first week, but certainly use it with year 11s as part of revision. So thank you, Andy, for yet another flipping amazing resource. Keep producing them, mate, please, because my teaching would not be the same without them. And I shall return with a fresh resource the week next week. Take care of yourselves. Bye for now.